So I don't have any, the only announcement I really have is that assignment 2 is due today. If you don't have that started, or even if you don't have A1 started, just get with me as soon as possible. It's still not too late to get going with assignments, to get caught up on work. I know a lot of people have had some extenuating circumstances. Um, yeah, we can work through this, and there's a lot. We still have quite a bit of time before the cutoff, which is, to remind everyone, March 30th. So please, uh, I want everybody to take the deadlines seriously, because things are going to begin to ramp up, and we want to finish out strong and kind of manage your workload very well. But if you feel very behind right now, now is the time to get in touch with me or get in touch with your TAs. Other than that, I will, yeah, that's all I have. Give it back over to Carrie and the Kahoot music.
Okay, let me get all this back on. Gonna share my screen again. Okay, should have that there. So we got 30 people. If anybody wants to jump in at the last second here, go ahead. We're going to cover our topics from the last class as usual. Let's do a little bit of a review. And then we will move on with tonight's topics. Okay, I'm gonna get started, but you can still join if you're still on your way. Okay. Last 9, almost halfway done, guys. All right, quiz question. Which is not a tool we're using for building Java web applications? Yeah, good job. Angular. That's something that is a purely front-end framework that we talked about in Unit 1. And certainly when you get to Unit 3, aka Liftoff, you can put together a full stack application with Angular as a front end. But for this unit, we're focusing on Spring Boot with Tomcat and Gradle. And on Thursday, you're going to learn a little bit of Timeleaf, which is going to give you a way to do some front end templates within the Spring application. So that's kind of where we're at. All right, Brad in the lead, but only just. What does MVC stand for? Great job. Model view controller, that is correct. Mostly Victorious Coder. You can hang on to that one for morale purposes if you would like. Okay, true or false? A controller manages the flow of data between the view and the model. True. Great. Yeah, this is throwing you guys some softballs up here up front. All right, put these in order. What is the sequence for creating a new Java web app with Spring Boot? Good. Okay. Yeah. So you can, kind of create the, get a general like starting file for the entire project with Spring Initializer online and add dependencies and all those things all at once. Then open it in IntelliJ, make sure it builds and runs. And you may remember if you check it in the browser, you'll have a white label error page, but that just means it successfully is sending something, or it successfully is running. It just hasn't sent anything yet. So then you code your controllers for your route path and any additional routes so that data can actually be sent to the browser and display on the page. All right. Where can you locate your application in the browser once it has been served locally by Tomcat? Yeah, good job. Localhost 8080. That is correct. True or false? It's normal to see a white label error page in the browser when you run a newly created Spring Boot application. I may have given that away already. Forgot that question was in here. True. Perfectly normal. Like I said, it just means that the application is running. It just means you haven't sent any data to the browser yet. Okay. Another puzzle. What are the parts of a URL after the scheme from left to right? Okay. Yeah, so this was a kind of a throwback. I mean, we talked about it last lecture, but it was also a throwback to Unit 1 where we talked about it in a little more detail. After the scheme, which is like HTTP or HTTPS:// you have the host, which is kind of the domain, and any sort of port, if there's a port, like 8080 with Tomcat. The path would be anything that is separated by slashes. And then query string is anything with the question mark and then after with the key value pairs. And those always have to come last. And it's important to know these because of the way that you are, setting up all of these routes and handling query parameters and path parameters with your controllers. All right, multi-select. Which are valid annotations to apply to parameters of controller methods? All right, so yeah, so response body and request mapping are used at the class or the method level, but for the parameter level, inside the parentheses of a method, you're going to use either path variable for path parameters, or you're going to use request param for query parameters. All right, King Goose in the lead. True or false? The response body annotation should be applied to controller methods when they're using templates. Yeah, so that's false. Response body is really only needed when you don't have templates because it indicates that you are going to be returning a string value that is to go and to be displayed on the page, and you're just returning that directly as a string. And that's what we were doing last class. We basically had either just plain text or it was HTML presented as plain text. But either way, we just returned that for those GET requests, and it would just got returned to the browser, and that's what went on the page. But if you're using templates, you don't need that. So you don't have to indicate that you have a response body being returned. Okay, true or false? A form element needs to have an action that points to the route where the user should be sent after form submission. Yep, that's true. Got to tell it where to go. Okay, ZC in the lead. Last question. This is going to be a tough one. You're going to have extra time and double points. What is the URL for this form page in the browser? So look at the code and then tell me what the URL is in the browser where you would find this content displayed. All right, 10 seconds for the stragglers. Okay, great job, guys. Yeah, so you know, I don't have the code in front of me. Oh, here we go. Yeah, here's the code. So let's talk about this. For those of you who didn't get it right, what we have done is we have applied request mapping to the entire class for this controller, which means that the starting route is /collection. That means that anything that we apply mapping for as methods inside that class gets tacked on to that. So that's why it's /collection/form. And so then that's pretty much it. But then of course it's localhost 8080. This collection/styles here that you see in the code is actually just the action, so that once they submit the form, they're going to go to that, and then that controller would be called, which is a completely different controller from this one. So yeah, so that's it. This particular content is being returned as a response body, which is indicated up here, to localhost 8080/collection/form. So good job. All right, let's see where we are. Molly in third place. Congrats, Molly. King Use in second place. And in first place, we have VC. Great job. Maple and Nina shortly behind them. Okay. Good job, guys. And now I can't see my, here we go. All right. Great. Okay, so tonight we are going to, kind of walk away from Spring for just a second and talk about exceptions and debugging and IntelliJ. Don't really have any announcements, so it'll just be a lecture and studio, and then come back for a short studio review. So with exceptions, we're basically talking about, just like we did in Unit 1 when we were doing this with JavaScript, it's the idea of anticipating what kind of errors might break your program and then handling them. It's very intentionally handling them. So we'll talk about what that looks like in Java and how to handle them, and then how to write a custom exception if you want to. We'll do a little bit of that. So you may remember that with JavaScript, you could have both, compiling and runtime exceptions that wouldn't happen until later because it is a dynamically, typed language. And with Java, it's pretty much going to catch most things like type mismatches, syntax errors during compiling, and it won't even compile the program for you. So all of that's taken care of up front. But you can still have runtime exceptions, and they don't actually happen until that particular line of code runs because something is not quite right. Or it can be, also be like logic errors, right, that you have. Well, no, logic errors are separate. So yeah, one thing at a time. We'll talk about the logic errors when we get to debugging. So here's some examples of built-in exceptions in Java. Null pointer exception. If you haven't seen this yet, you will. It's very common if like an object isn't found, or you try to convert something from one type to the next, and it's impossible, or something is just literally it's just not there, or you can't do with it what you were trying to do with it. Index out of bounds exception. This can happen for indexing with arrays or with strings. There's actually different versions of this one. Arithmetic exception, dividing by 0, taking the square root of a negative number, things like that. Although it's actually square root of a negative number does not trigger an arithmetic exception, and we're going to see that tonight. You actually would have to handle it manually because it'll actually just return not a number, but that's problematic if you're trying to calculate with that, right? So so we're going to look at how to handle that. If an exception is not handled, your code it just stops, it breaks the application, nothing after that runs, and boom, the application breaks. So it's really important to try to think about all the things that could possibly happen. And might just be because somebody's not using your code the way you intended them to, not because you didn't write good code, but you want to think those things through and then handle them so that it doesn't break the program, but it gets handled in a way that the person who's using your code might say, oh, like I should have used that differently. So when you are handling exceptions, you're essentially just thinking through, what are the possible problems, planning for it. And there's some, very specific syntax for that. You're going to need to use a try-catch block in order to do this. And you can catch an exception as is. So if you had some sort of exception, like a null pointer exception, or actually, I think we're going to do an example of, which one did I set up? Oh yeah, an index, an out of bounds index. We're gonna look at one of those. You can actually, if you know that it's going to happen, then you can just catch it and you don't have to throw it. But you can also deliberately throw an exception when you want to be able to force something so that you can then handle it. And you use the throw keyword, and you can do this all in one line just by creating a new object of the exception type with that new keyword. So we can see that here. We've got a try block. This is the code that may or may not cause an error, but you definitely need it to run and check. And then you might have this, condition and say, if this condition is met, then we need to trigger, this exception here. And use that throw keyword to throw it if that's what you're going to do. And then new arithmetic exception in this case is the particular type of exception I chose to throw. And I created a new object of it. And through it. And then this catch block here is basically saying, okay, if something has been caught, whether you threw it or whether it just happened, then we're going to, in this case, all we're going to do is print the stack trace, which includes whatever message we gave it. But that code only runs if the exception is thrown. If you had something where you weren't deliberately throwing it and everything's fine and it just kind of goes through, or, if this condition isn't met and it skips this, if block, then it's not going to catch anything. So it'll just bypass this and just continue on. But the important thing is that even if it does catch it, it'll still continue on. It doesn't stop and break the program. So you're still going to get this return statement afterward, even if you catch this thing. And in this case, I just, decided to handle it by saying, okay, so if they pass in a negative number, we want to call it out and say, hey, print something to the console that says, hey, you were trying to take the square root of a negative number, but we're going to fix it by allowing it to take the absolute value to make sure it's positive instead, and just return that. So we can code this. Let's do both of these since I've got this other one as well, the index that doesn't exist. And make sure this is a little bigger. Okay, so I've got some little methods down here to help us out. This is the main method, but below that there's this print element that literally all it does is print the element that's at the index of that array, right? But just for the purposes of showing kind of how you would use, set it up to handle it in this separate method, I did something very, very simple. So the idea here is we can try to run this and we'll say, we've got these strings that are all in this array, and we're going to print from that array index 7, which of course doesn't exist. So if I run this right now, I get this, message here that says, exception in thread main java.lang. And this is just the built-in exception. And it says index 7 out of bounds for length 5. That's the default message for that exception. With a little bit of detail, it's given us a specific index and all that stuff. And it tells us where. And then it just finishes. So you'll see nothing on these other lines of code, it didn't continue, right? It broke the program. So this is where we have to say, okay, if someone accidentally was to use this and pass in an index that isn't valid, we would need to have a way to handle that. So we can go down into this method here and actually handle this. And the first thing, of course, is we have to have that try catch block, right? So we'll set that up. And we'll say, catch, and then, have that. So you need to have this try catch block first. And then we can actually put the thing we're trying to do inside the try block, which when we're just printing, that's really all we have to do is just say, try that. And if we get that array index out of bounds exception right there, and I can actually, grab that text and copy it, make sure it's exactly the right one I want. If we get that exception, and we're just going to call it E for exception, then instead what we're going to print is the message. And all exception classes inherit from a class called exception that has, all of these things like, print stack trace and get, this is just the getter for the message that's stored. So we just do e.getMessage and we'll print that and we should be good. And, as opposed to printing the entire stack trace that we already see here. But now that we're handling it, what should happen is it's going to catch it. It's going to print our message for us, but then the code should continue and we should see what happens next. So let's run this again. Yeah, so we get index 7 out of bounds for length 5, and then it continues. The square root of 16 is 4. The square root of -5 is not a number. So this brings us to our next thing. Now we have these, this get square root method that you give it a number, it gives you the square root. But there's no such thing, we're not dealing with imaginary numbers. So it just says not a number. And if you were using this in conjunction with a bunch of other things where it needed to calculate or it needed to do something that it needs it to be a real number or it's going to break, then you kind of have to have a way to hand that. And you say, well, the attention, probably whoever was using this didn't realize that they were passing it in as a negative number and they probably should have passed it in as absolute value. So let's just handle that for them. But we'll also print something to the console as a warning. So let's do this. So instead of just returning, the square root of n, we're going to actually fill this out a little bit. And this is where, we're going to code basically what you saw in that slide, but we'll do it step by step. So again, you need a try catch block. So we'll, say catch like this. Okay. And the first thing we'll do is just check, is in, because we're going to have to manually throw an exception for this one, since it automatically converts it to not a number and doesn't actually throw an exception, on its own. So we'll say if n is less than 0, then we want to throw a new, and you'll see, arithmetic exception is the first one that comes up. And then I'm going to give it a custom message here, and I'll say, warning, cannot take square roots of negative number, and then I'll add on n to customize it a little bit. So it'll only throw it if that's true, and then we'll catch it. So we'll say if we get an arithmetic exception E that's thrown, then let's print that stack trace. We'll just print the whole thing. But when we do, we should see our custom message, because this goes, directly into the constructor of the exception class. Grant, you got a question?
Yes. So on just to go back to the print element try catch, can you recall print element within print element in your try block?
Recursively?
Well, I guess it would be recursively, but like to just try and get, for your try to be, or the try wouldn't, or the catch be to recall the method.
Yeah, I'm not sure how that would turn out. I mean, in this case, we don't know what index they probably really wanted, that they gave us
Right.
the wrong one. So there's kind of no way for us to fix it. I mean, really, my intention here was just to print a message to just say, just make, like, this probably would have happened, it would have, essentially the only difference what we're doing here is just keeping the program from breaking. So we're saying, and I could have just print the stack trace and then it would be exactly what happened without it, except that I'm keeping it from breaking by using catch.
Gotcha. Okay.
Yeah. Okay. So back over to our second example, we have try if it's less than 0, throw the exception, and then when that exception is caught, print the stack trace, but then continue. And then here's where, we no longer want it to give us not a number, NaN. We want to make sure that it's actually going to give us something that is a real number. And we're going to assume, based on how we know that our code is meant to be used, that they really just meant to get the square root of the absolute value of n. So I just use math.abs for absolute, and that will make it a positive number. So then it takes it and we actually have a real value. So now if we go and we run this again, we see, index 7 out of bounds for length 5, the square root of 16 is 4, and the square root of -5 is 2.236, etc. And then it prints the stack trace here, and then it continues, although we don't have anything left to prove that it continues. We could prove that it continues. Let me put something here. Code continues. All right, let's run it again. Yeah, code continues. Now, sometimes it prints the thing after at the bottom, but it did still continue on. You'll notice it didn't break the program. It continued all the way through. So that's another way you can sometimes handle this. And then the third thing is using a custom exception. Let's go back to the slides for a second. Okay, so maybe you want to handle a special situation and you want to just create your own class to handle things exactly the way you want it. And this especially might be if you want to do something other than passing in a message, which is what I'm going to show you how to do. So let's say I've got this idea of, I want to be able to process something that depends on the words having to have vowels. This is kind of a silly example, but let's just say that's the condition, right? What happens if we do get a word that doesn't have a vowel? We need to have a way to handle it. So you can use class inheritance from the exception class to create your own class. So, and then you just pass the message to the constructor of the exception class with the super keyword, just like you would with inheritance as usual. But that gives you the freedom then to be really creative with how you build the message and also how you create the constructor of your custom exception. So you'll notice here that while I'm passing, I'm inheriting from exception, and then I'm using super to pass the message that the exception class constructor requires so that it can print that as part of the stack trace. But I'm not actually taking in a message here. I actually am making the constructor of the no vowel exception take the word, because I want to be able to print it and say, you know, this word has no standard vowels. And that forms up the message that is required by the parent, by the base class. So does anybody have any questions about that so far? We'll code it in a second. Let's see how it works out. Okay, so let's take a look at this. Up here, it says, you know, print each word in the array, but throw a custom exception if a word has no vowels, meaning the standard vowels, A, E, I, O, U. And yeah, the custom exception should take the word as an argument, not a message. And we want to print the stack trace if the error is caught. So we're given here an array of 4 words: epic, fable, myth, and folktale, one of which does not belong. And I've just called it story types. So we can actually right here go through and you know, carry out this logic and make sure we have the exception handled. I do have a helper method down here, has a vowel. This is not where we need that handling to actually go. This is just for the purposes of checking to see if it has a vowel or not. Okay. So we're going to be making use of it, but we're actually going to just handle the error right here. So when we start, we really just are going to set up a loop, right? We just need to look at them word by word. So I'm going to say, you know, string story type of story types. This is a for each loop. And then this is where, you know, normally I could just say, print, the idea here is that we want to just print the word, but we don't want to do it if it has a vowel. So I'm going to do a try catch block so that we can set this up and make sure that we're only printing it if it actually does have a vowel. So I can say, you know, like 2 things can happen here. Either we can print it or we can throw this custom exception that we're going to create. And I just realized we haven't created the custom exception yet. So before we do anything else, I mean, we can kind of have the, you know, if else idea here. And so we'll just say, you know, if it's not, if it doesn't have a vowel, throw exception, and we can go ahead and do this part. If not has a vowel, there we go. And then I'll give it the word story type. So if it doesn't have a vowel, if this comes back false, we'll throw the exception. Otherwise, we'll print story type. And then down here, we'll catch our exception and print the stack trace, but we haven't created the exception yet, so we need to go do that. So up here in my package, class 9, I'm going to create a new class, and I'm going to call it no vowel exception. And it is going to inherit from exception, extends exception from java.lang, which doesn't require an import. And then I create my constructor. So, you know, public no vowel exception. And then we remember I said I want it to take the word in. I don't want it to take the message, because we're just going to have a standard message that we pass to exception class here with super. So I can create, let me remember what my message was here. Yeah. Okay. Warning. The word has no standard vowels, because apparently that's important to us. All right, I'm going to put a little single quotes around that when it prints. Okay. And that's all I need to do. And that takes care of it. It passes that message to exception, and then exception, this now no vowel exception has access to the print stack trace, get message, all those things that come with the inheritance. So back over in main, we can say here that we want to throw a new no vowel exception now that it exists, and we'll just pass in the word. And you can see it's telling me it takes string words. So I'm just going to pass in story type. And then down here, we'll catch it. Why is it complaining? Oh, because it's unhandled. Yeah. Okay. IntelliJ is being too smart, guys. It's not giving us a chance to finish coding. Okay. And then this is where, I think, yeah, the instruction said just print the stack trace. So we can do that. E.print stack trace. That's one of the methods that comes built in with exception. So let's give this a go. It's going to loop through each of these, and it's either going to print the word or it's going to throw the exception and print the stack trace, but it will not break the code. And that's the important part. Okay, so we get epic fable, and then we get our stack trace, and then we get folktale. So, warning, the word myth has no standard vowels. So I realize a little bit of this is it's abstract, right? It's hard for you to imagine how this fits into something, more robust. But that's kind of how these things go. It's like without having a massive code base and really explaining the context of all of this, it's hard to give you a more concrete example. But that's okay, because you really just need to understand why it's important and how to do it. And then when you get into a job and you start doing this stuff, if this is the kind of work that you do, you're going to get real good at this real fast, because it's, pretty standard practice to make sure you handle all your exceptions that you can think of. Okay. So that's pretty much it for the exception stuff. Any questions before I move on to Gradle and debugging?
I had a quick question back on IntelliJ. Whenever I stepped away for a second, so I might have missed it if you changed anything, but before your code continues and square root was happening before the stack trace, and now it's happening after. I was wondering why that changed.
I do not know why. It might just be because it's asynchronous to some degree. And
Okay.
so, it's printing things out, and it spits out the stack trace when it spits it out, and it just may fall in line and it may not.
Okay, thank you.
Sometimes those processes are run at the same time, but they're asynchronous. Yeah. Okay. All right. So let's talk about IntelliJ tools and debugging. But we'll also look at Gradle a little bit. And that's a good idea to understand a little bit more about what Gradle is. So Gradle is a build automation tool to create an application, which is a fancy way of saying it makes it really easy to just automatically put together all the things that make up your application and get it running. It integrates, your frameworks, your dependencies, your language. It runs tests, and it compiles and packages the code. Gradle is great at, any sort of automated tool is going to be great at providing a consistent process, and Gradle is especially good at it. Works with multiple languages and platforms. It can also be used like Android and some other things like that. It works with multiple IDEs. People will use it, not just with IntelliJ, but with Eclipse and things like that. It's nearly twice as fast as Maven. There's a number of ways in which it improves on Maven. But it integrates with like Maven repositories and stuff. So it still works with all of that. And it's very flexible and easy to maintain. So you have this build.gradle file that outlines everything, and then you just go and you make adjustments as you need to, but you'll still be able to count on it, being able to put everything together. So this build.gradle file is essentially a script. It outlines the build process. And anytime your application is built or rebuilt, it's going to go and reference this and say, okay, what do I need to build this application? And so all of the different things that have to be integrated, they could be the plugins, and you could see, in this example, you've got Java, Spring Framework.boot, and the dependency management part of Spring. Repositories, Maven Central is where the source code comes from for these dependencies. The dependencies themselves, references to which external libraries are needed for the program. And then I don't have an example of the configurations here, but that can be another thing that maybe there's ways in which some of the dependencies are packaged up or things like that. And then it has a tasks method, which can run tests. It can do anything else that you need to do to include in the process to make it all come together. But it's nice and it's easy to read. This uses essentially a language kind of based on Groovy that is much easier to read than something like XML, which is what Maven uses. So I appreciate Gradle because it's much, much easier to read. So that's just, these are helpful things to know when you are trying to get your head around what all of these different moving parts are. This is the part that makes it all, this is where it all comes together. So if you run into issues with dependencies and things like this build.gradle file might be the first place you go just to make sure that you have everything you're supposed to have. And then it knows where to find it. But Spring Boot creates this file for you so that you don't have to create it from scratch. So when you go to the Spring initializer and you set up all of your initial information, part of what it's doing when it's building that, project file for you is creating this file for you. That being said, if you want to be adventurous and create your own, you're certainly welcome to. So the debugging process is a much better way to find errors than just logging things to the console. And IntelliJ has a very, very great built-in system for this. So as I was saying kind of earlier, your code can compile and you can still have, runtime exceptions that you would have to handle. And then you can also have logic errors, which just means it didn't come out the way you expected to. You've got some logic in there somewhere that's wrong because 2 + 2 is suddenly equaling 5 and you don't know why, right? So this built-in debugger will make it easy for you to find where it's happening because you can kind of look at things one step at a time. So you set breakpoints, one or more, which is this little red dot you see in this example here. You just kind of click and toggle that on right next to the line number. And that will say, okay, make the code run as normal until it gets to here and then stop so I can look at it. And then you run it in debug mode, which is the little bug symbol that's next to the run symbol. You can choose to do it that way. And you can get to that from the other, context menu on the class itself too, but it's also up here. And then it'll run it in debug mode so that it pays attention to those breakpoints. If you hit run and you have the breakpoints on, it just ignores them. So you kind of just have to pay attention to which one you're running. And then when you are in debug mode, it's going to, stop there, and then you can kind of move through the code one line at a time and inspect the data values at each point. I noticed this is pretty cool that I'm going to show you in a second what it looks like in the panel at the bottom, but it was even telling me what the values are here, right here, line by line in the code as I was stepping through this, which I thought was pretty cool. Last time I used IntelliJ for this, I had not seen that, so it's pretty cool. So moving through the code when you're in the panel at the bottom, which is I need to actually have it up and running in that. I'll show you in a second. There's different buttons though, and these are the ones you're probably going to use the most, which would be step over. And step over doesn't mean skip. It means execute this line and then just move to the next one that would be the next thing in the logic to execute. But go ahead and execute it. That's all it means. If you see this downward pointing arrow, that means to step in. So maybe you have a line of code that calls a method. And ordinarily, if you just stepped over it, it would just go to the next line below that without actually going and seeing what took place inside that method with all of its lines of code. But if you want to be able to jump over to where that method is and then look at that code line by line, you can use step in. And then likewise, when you're ready to go back to where the method was called, you can use step out and get back to there. And I'll demonstrate this for you. Run to cursor is what it calls it, which doesn't seem to mean anything. You know, it's like, what does that mean, right? What it means is it allows the code to just continue on until another breakpoint is hit. So you might be like, okay, there's 200 lines of code now before this, my next breakpoint. I don't want to have to sit here and press step over 200 times or 100 times, whatever I said. So you can press the run to cursor, and then it'll fast forward, let the program run, and then stop again if there's another breakpoint, which could be in a loop. It could be the same breakpoint as part of a loop, or it can be a completely different breakpoint somewhere else in the code. But yeah, so these are kind of, you know, really handy ways to be able to move through everything. So the last part is looking at the data values. Yeah, and here's that panel. It was on the next slide. So you can kind of see the buttons right here for step over, step in, step out, and run to cursor. And this is where this panel is great because it kind of tells you, here's where you are in you know, this file, this line, at this method, and here is all the data that's available to you, and here's what their values are. And the values are actually what the values are before the current highlighted line has been executed, because it won't get executed until you hit step over or fast forward. So this, you have to keep that in mind. Those are the values before it's executed. But you can also enter custom expressions to evaluate. So like here, if I want to actually like evaluate that entire expression, AEIOU contains letter, I can, you know, do that. And whatever the current value of letter is, M, it'll, you know, give me the result for that. And this is all, again, much better than having to temporarily add a whole bunch of logs to the console to check all of these values. You can just kind of see what they all are, see how they relate, and it will help you arrive faster at something's wrong. And this is what clued me in, right? So let's take a look at how this works in practice. We're going to come back over to the same example here. And we're going to look at, let's see. Yeah, we're going to start by just looking down here at our has a vowel helper method that I wrote. And I'm going to put a breakpoint right here to just stop when we get to this loop before it starts to execute this loop. Because I want to kind of, you know, just see how it moves through it. So I can run this up here in debug mode, and you'll see it opens the debug panel, which you can always switch around between, you know, run, debug, terminal, etc. It's all right here. So opens the terminal, tells me where I am and what data it's got access to at the moment. And it has word is equal to epic and has vowel equals false, because has vowel has been set on the previous line and it has actually come into here yet, right? So as I'm going to step in one at a time. So I'm going to step over, not step in, sorry. I'm going to step over. Got to use the right terminology here. So that executed that line and moved us inside the loop. And now it's on this line, but it hasn't evaluated it yet. So you'll notice it says, you know, has vowel is false, even though you can see that it's telling us that this is going to evaluate to true. But has vowel itself is still false because it hasn't been set to true yet. So you can kind of see how this is working, right? You know, we're doing this one step at a time. And then, you know, we get to the next one, and that's where it says, okay, has vowel is false, but if we run this line, it's going to get turned to true. So then, you know, and you can see it down here too. So then as soon as I actually execute that line, now you see has value is true, has vowel is true. Okay. And then it moves on to the break, and it's going to break out of the loop and actually continue on. So if I continue, if I hit step over, it goes down to line 66 and breaks out of the loop, because that was the next logical step for this, rather than to continue looping through. So, you know, following, this is a great way to learn how your code executes too. If you're confused on what order things are and whether something gets hit or not, you can actually just go into debugging mode. Maybe you don't even have a problem, which I currently don't. I just want to see what order everything's executing in. This is a great way to do it. Okay, now let's introduce a problem so that we can kind of see, you know, how we would figure this out. So I'm going to say, let's say I accidentally got my logic screwed up and I said, if not, AEIOU contains letter here. And I'm going to stop this. And I'm actually going to move my breakpoint so that I can also demonstrate the step in and step out. Where are we? Oh, oh, here. Okay. So I'm going to move my breakpoint to here. Yeah, I think we'll do it here. So I'm actually going to move it to the loop where we're looking at one word at a time. Okay. And then we're checking to see if it has a vowel. So we'll start here and I'll start up the debugger. Okay. So it's telling me it's got access to story types, numbers as text we don't care about, that's related to something else, but story types, I know, is this thing. And it hasn't executed this line yet, so it doesn't know about story type, but it's about to, because I'm going to hit step over. Okay, yeah, so now we have story type equals epic, because now it's executed this, it knows that epic is the one it's chosen, the first one in the array. And but it hasn't executed has a vowel story type yet, so we kind of still don't know where we're going. If I step one more time into this, or over it, I should say, you can see that it bypassed it and said that it was going to, yeah, print it. Is this working the way I expected it to? Hold on. That has a vowel story type too. Interesting. Okay. Story type equals, yeah. Okay. Sorry. Just want to follow my own logic here. Yeah. Okay. And then it bypassed the exception and it just printed it. And then if I do it again, it's going to go back up to the top and we get here and we can see, okay, now it's looking at Fable. And interesting. I was expecting it to do the opposite of what I thought it was going to do. Okay, so now we're at myth. Aha, yes, okay, right. So it's still bypassing it. We would have expected that it was going to throw the exception here because we know that myth doesn't have a standard vowel, but it didn't, it bypassed it. So this is where we know we have a problem. And so what I actually would prefer to do, I'm going to stop it and restart it, is yeah, let's go in here, go to epic, and I can actually say, okay, Fable, that's not the one I want. I'm going to use this run to cursor to have it go all the way back up around. Yeah, so now it's here. And if we go here, myth, this is not one I want. So this is where I'm going to step in because this is calling has a vowel. So I can say, okay, I need to go look at what's happening in here because I know that this ended up not throwing exception and I expected it to. So I'll use step into, and then it flips down here and takes us into this. And now we can look at this line by line. So we know, word is myth, and then I can step over. And here it says, that that's going to be true. And I'm like, wait a second, like I was actually expecting this to be false. So why did it come in here and break out, right? And that's where I could say, oh, I've got a logic error, and fix it here. And then after that, I would expect it would work perfectly. So yeah, that's the idea. Figuring out where you want to put your breakpoint can be part of the challenge. Maybe I, already knew which word I wanted. And so, I could kind of, oh yeah, that's the other thing I should show you. The conditional. I think I have a slide for that. Hold on. Aha, yes, conditional breakpoints, right. So you might say, I don't want to have to go word by word by word. I know what word it is I'm interested in checking. Let's just flip straight to that. So you could have a condition on your breakpoint that says only stop if story type is myth, right? So you just right click on the breakpoint to get to that. So let's do that. Let's keep this here, but then I'm going to right click on it and say if story type equals myth. And now you can see it's got this question mark on it, and that indicates that it's got a condition. So I can run this again and oh, yeah, it can't find it because it hasn't created it yet because this hasn't executed. Yeah, that's my bad. Okay. Sure. Okay. Let's just stop the whole thing. I'm going to fix this. Let's put it here and do it here. This is why it's helpful to know how this works. Yeah. So just in case you weren't clear on why that happened, if I have the breakpoint on this line, it hasn't actually executed this yet, which means it doesn't know what story type is. That's why it I couldn't evaluate the expression story type equals myth because it didn't know what it was. So you need to actually have your breakpoint be inside of that so that this already exists at that point. So now I will run this again. And this time, we will see. Did I actually regular run it? Oh no, here we go. All right. Why is it not debugging?
Could the problem be the double equals sign instead of a dot equals for checking string equality?
Yes, that is an excellent point. Okay, let's do this again.
I have this problem all the time.
Yes. And this is why, you know, I'm a JavaScript mostly. I forget sometimes these things for Java. Okay. All right, so we will try this again. Story type and then equals because it is string comparison. Okay. And then we would say myth. So let's try that. Yeah, good call. Okay. Yeah, so now you can see that even though it already had, had to loop through on Epic and Fable, it skipped those because I said, don't stop at this breakpoint unless story type is actually myth. Wait until we get to that particular one. And you can imagine that if you had a really, really like big array or whatever, collection of some kind, you would not want to have to go through so many loops over and over again. So this can be a really useful tool. Thank you for helping me figure that out. Simple mistake to make, but there you have it. Okay, so great. So let's get on to Studio. All right. So you are going to review your class 7 Studio spinning disks and go back to that repository. And then if you want to take a look at the branches that are available remotely, you can use git branch-r, but you should be able to just use git checkout debugging to switch to it. And this is something they've set up for you for this Studio. And then you'll follow the instructions to practice using these tools in IntelliJ. There's also a portion at the beginning where you can just kind of, discuss. When I was writing my version, ask yourself the question, when I was writing my version of the Studio, because everybody did it differently, what kind of errors did I come up against and what would have been really nice if I'd known how to use the debugging tools for this, right? But then you can actually use the debugger or debugging branch to use LaunchCode's version of the Studio solution and kind of come in and figure some of these things out, and it just walks you through it. So we'll come back later and I will model this for you, but it should be pretty straightforward. And you might even have some extra time to work on some other things or talk to your TAs about graded assignments or whatever, because this tends to not be a super long Studio. And then on Thursday, we're going to talk about Timeleaf. Very exciting. You guys will get to, it's not, Timeleaf is not as robust as like a front-end framework like React or Angular or something. But it does allow you to have a nice way to have templates in a Spring project for a Java web application. So it's a nice tool. So I'm looking forward to kind of helping you guys get the basics down on that. And then you're going to be able to really have some fun with your creating these little web applications for the rest of the unit. And then we'll talk about models and model binding, which is important for that too. Like, having classes with objects that are being used as part of the data that you're displaying on the page or saving information to, that sort of thing. We're going to start getting into this in the next week. It's going to be good. All right. Head on over to Studio. I will see you back here at 8 o'clock.